All right, it says we're recording. How many people do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's pretty good. All right, so we're going to talk about Chapter 9 today. Oh, I was going to mention, somebody asked me, they noticed an assignment that said August 25th. And remember, that's just, I'm going to give you 5 points. I tried to grade that really quick right before class today. 5 points for being on time and on camera. So, so thanks to you all. So that's what that's, and that's extra credit towards the end of the semester for on top of your grade. So I'll just average the 5 points over the whole semester. So, all right. So we're going to talk about observational studies versus experiments. Before we do that, I think we talked about census last time. The idea behind a census is that you attempt to include the entire population in your sample. In fact, it would be the entire population. It wouldn't be a sample. This is best, but it's not always practical. Actually, there's some cases where it's not the best. I think we talked about last time, is it good to test every light bulb to see how long it lasts? No, because you wouldn't be able to sell any light bulbs, okay? All right, observational studies. Observational studies, just like it sounds, you observe and measure responses, but this is the key thing, you don't attempt to influence, okay? So sometimes this is the only way to conduct studies due to ethical reasons. In fact, before we go into that, let's talk about experiments. An experiment is to deliberately impose some sort of a treatment on individuals in order to observe a response, okay? So let me give you an example here, and I want you to tell me this example right here, if it's an observational study or if it's an experiment, okay? So a Danish study kept track of 420,000 Danish cell phone users between 1982 and 1995. They compared the rate of brain tumors to people without cell phones versus people with cell phones and found no difference between the two groups. So I'm going to ask you guys here, we're going to do our first poll question of the day. Is that an observational study or is it an experiment? And give me a thumbs up on whichever one you think that is. And I'll put it back here so you can read it again. So Danish study kept track of 420,000 cell phone users and compared the rate of brain tumors in people with cell phones. In fact, I probably should put that with cell phones versus without cell phones. And they found no difference between the groups. Okay, looks like we're getting some responses here. Let's peek. Okay, now how many people we've got? 9, 10, 11, 12. So we've got 8 answers so far. What does yes mean, Noel? It's one of the two. Sam says it's an experiment. What does thumbs up mean? Thumbs up on the observational study or the experiment? If you hover over where it says observational study, it'll pop up a thing and then you can put your thumbs up.
Sorry, I'm having a little technical difficulties with my computer.
Yeah,
Oh,
mine's
okay.
not popping up, so it still must be logging me in as guest.
Oh yeah, Sam, you are logging in as guest. Do you have the app?
I have it on my computer, yeah. It should be.
Did you log in before we started?
Yeah,
And it's
thought
not,
so.
It's not the web app?
I have Microsoft Teams on my computer, so I just used your link and it popped up with this.
Huh, weird. Okay, yeah, usually the first time it asks you to log in and then you don't have to log in again, but. All right, so most of you said this was an observational study, and that is true because we did not impose the treatment. The people imposed it upon themselves, I guess. We didn't attempt to. If this would have been an experiment, I would have taken half of the users and I would say, you have to use a cell phone for 8 hours a day. And then the other people, you can't use a cell phone. So that would have made it an experiment. Okay, now let's talk about this other scenario. Group of rats divided into 3 groups. The first group received analog cell phone radiation for 4 hours a day, 5 days a week for 2 years. I gotta fix all my typos in here. Second received digital radiation, so the only difference between is one's analog, one's digital. The last group was the placebo group. They received no radiation. Cancer rates were compared and no link was found. So let's do a new poll. Is this an observational study or an experiment? So give us a thumbs up on the new one. I'll put it back if you want to read it here. That's what we're looking at. Okay, 8. Almost got everybody responding here. We've got 9, 10, 11, 12. Who hasn't voted?
Have good enough internet connection to see the poll. Sorry.
Oh, you're driving? I hope you're not driving. I hope you're a
I'm just
passenger.
a passenger.
I'm glad to hear that.
Yeah.
I don't want you driving and getting in a car accident. Okay. Nope. All right. Okay. So, and did you tell Mallory? Did you say what your answer was?
Experimental.
Experiment. Okay. So yes, that is an experiment because we are imposing a treatment on the rats. So we're giving one group of rats cell phone radiation, and rats don't have any choice. They're going to get it or not. The other one's going to be digital cell phone radiation, and then a third group is going to be no radiation. Okay. So experiments are usually preferred, but they're not always ethical. Would it be ethical for me to force half the room to smoke and the other half not to smoke? How many of you would volunteer for that smoking study? That's what I thought. Nobody raised their hand. Okay. So yes, so I can't force people to do certain things. And so a lot of times we have to rely on observational studies like this Danish study about cell phone users in order to try to do that. The problem is, well, actually, I'll tell you the problem in a minute. But okay, there was a study done in the 1970s said that sugar caused heart disease. And then I'll ask if anybody's heard that, but later studies showed there was no link. The original study was flawed because of confounding. So let me ask you first, for those of you who are on camera, you can raise your hand, and if you're not on camera, you can kind of see what I'm looking at. Anybody ever heard of the sugar study in heart disease? Okay, that's what I thought. So yeah, so there was the study done, and the problem was they did not, well, we had confounding go. So a lot of times I like to say confounding, you can think of that as conflicting results, but the definition of confounding is the effects of two or more variables are not separated. So the problem with the original study was they did not determine who was a smoker and who was not. So did you guys know that smokers consume more sugar than non-smokers? Who knew that? Yeah. So that's kind of an unusual. Do you knew that, Clark? I kind of knew it. Did we talk about this last time in class? Sometimes I get my classes mixed up. I don't think we did. Okay, we talked about it in another class. So here's the reasons. So remember, this was done in the 1970s, and there was no Starbucks back then, you know. And the reason why Starbucks is so good is because they put so much sugar in their coffee now. Back in the 70s, you had to drink your coffee black, and you could put your own sugar in. And apparently, smoking causes people not to taste as well. It kind of kills your taste buds. And so if you wanted to be able to taste that sugar in your coffee, smokers would put a lot of sugar in their coffee. And so it was one of those unusual things. And so because the original study users did not take into the effect smoking, they didn't know that smokers drink a lot of coffee and it kills your taste buds, and therefore they ate a lot of coffee or a lot of sugar in their coffee. So when smoking was taken into consideration, the effects of sugar vanished in relation to heart disease. So smoking was the cause of the heart disease. It was not sugar after all. And so smoking became what's called a lurking variable. So the definition I like to use for lurking variable is what you forgot to include in your study. And so in this case, smoking was your lurking variable. So the idea lurking variables and confounding, those two things always go together. So confounding says you've got two or more variables that are not separated. In this case, it was the sugar and it was the smoking that were not separated. And smoking was the lurking variable because the original researchers didn't track that because they probably didn't know that it mattered. So anyway, that's kind of interesting. So often observational studies are used because you can't do experiments for ethical reasons. I can't force people to smoke, can't force people to go to church, can't force people to have abortions to see if it affects the health of the mother. And so we must rely on observational studies for many of these things. Okay. And the problem with observational studies, often you have confounding and you have lurking variables because it's hard to control what happens. Okay. An experiment is a controlled study to determine the effect of one or more explanatory variables or factors has on a response variable. So any combination of the value of the factors is called a treatment. Okay. In an experiment, we take an experimental unit. Last time we think we called those individuals, or sometimes we call them subjects. So a subject is a person, object, or some other well-defined item upon which a treatment is applied. We often refer to experimental units as a subject when it is a person. A subject is analogous to an individual on a survey. Okay. In an experiment, we often have a control group, and that serves as a baseline treatment that can be used to compare other treatments. Okay. So usually we also have what's called blinding. Blinding refers to non-disclosure of a treatment that the subject is receiving. There are two types of blinding, single and double blinding. So with a single blind experiment, the subject does not know if they're receiving the drug or the placebo. And in a double-blind experiment, both the doctor and the patient don't know. So let me ask you guys, why do you think that it would be good for both the doctor and the patient not to know if the patient's getting the placebo or not?
I think the body language.
The body language?
Like if the doctor knew, sometimes it'd make the patient uncomfortable, or they might notice something was off, so it might change the results.
Might change the results. Why would the doctor change the results? Are doctors unethical? Is that what you're saying?
No, so they've done studies in the past to point out that like a patient will believe that they're feeling something or that there's a change or something simply because they think they got the medicine, even though they didn't. Like they'll start feeling better even though they weren't given any medicine.
Okay, so you're referring to actually something a little bit different in the placebo effect, and I think we're going to talk about that a little bit later. If not, we will talk about that. But the idea here is, actually, before I give that answer, does anybody have anybody else have a reason why they think it might be a good idea for the doctor and the patient not to know about the treatment?
Could it cause bias?
Bias how?
Sorry. the doctor and the patient don't know, then there would be no bias in what they think is going on. That doesn't make much sense. I don't really know how to explain it.
Okay, anybody else?
They might interview both the subject and the doctor, so that if neither of them knew, then neither of them would actually have bias, and it could be a more accurate representation of what happened.
Okay, yeah. So the idea is sometimes, even unconsciously, doctors might introduce bias in there. And so if the doctor knows that a patient got a drug, for example, they're going to expect them to get better. And if the doctor knows that the patient didn't, maybe they won't expect them to get better. Now, Sam mentioned something of, I might not talk about, we'll go ahead and talk about it today, called the placebo effect. I wonder if that's in our next, no, I don't think it's in our next one. So in fact, let's talk a little bit about the placebo effect here. But here, I'll finish this off first. Sometimes a doctor may bias results by treating only those he think will benefit. And so double blind helps alleviate the problem, okay? So it makes the doctor a little bit more honest in his evaluation, okay? So explanatory variables are used to explain why a result might happen, and a response variable is the response that the experimental subject might have. Now, let's talk about the placebo. Placebo is a dummy treatment, okay? And so it's very useful in drug studies. It's very easy to give somebody a pill and say the person has no idea if the pill is the drug or if it's just, you know, a sugar pill or something. And so the idea here is it can be used as a control group. And so you can decide if the placebo group doesn't get better and the drug group does get better, then you can know that yes, it was the drug group. Now there's also a thing called the placebo effect. Okay, and the idea is sometimes people get better if they believe they are getting a drug. Now, I'm going to give you an example here. There was a study done, and it's amazing that people can heal themselves if they believe that what they're taking is working. So there was a study done, and it was to cure baldness. I think it was mostly men, but women do get bald too. But in this study, they recruited a bunch of bald men, and they gave them a drug. And so it was amazing because I want to say 40% of the men who received a placebo or a dummy treatment grew hair. Like hair physically started growing out of their head because they believed that they were getting a drug. And so it's amazing what your mind can do when you think that you're getting a treatment. On the other hand, they gave a drug, it was called Rogaine, and 80% of the people who took Rogaine actually grew new hair. So they compared the 40% versus the 80%, and they said, oh, well, we can see that clearly the drug group worked better. But it's an interesting thing, this placebo effect, because your mind can do some amazing things. And so that's kind of a little bit what Sam was saying. And that's kind of referred to the placebo effect, okay? All right, now let's move on. We might talk a little, actually, before I do, I want to just mention a couple of other things. It's really difficult to do placebos on other things like diets, okay? So I'm going to give you this plate of salad and you think it's meat, right? Do you think I can fool somebody that a plate of salad is meat? it's getting a little bit harder now that we've got Beyond Meat and Impossible Whoppers and stuff like that. And by the way, I will tell you what, I actually, a couple of years ago, decided I was going to try to become a vegan. And I love meat. I'm just trying to do it to be healthy. But have you guys, who has had the Impossible Whopper? Only one? Okay. I'm telling you, it is awesome. It is every bit as good as a regular Whopper. I've become a huge Burger King fan. But at any rate, so typically, I mean, maybe I could sneak some Impossible Whoppers in there, and you think you're eating meat when you're really not. But diets are really hard to do. Surgery is another thing. Do you think it's ethical to carve open somebody and then just sew them back up so that they think they got surgery when they really didn't? Is that ethical? Okay. Now, recently, it's funny because the problem is when you do that, you can actually introduce infection. They've actually done, I need to post a link, but there's Freakonomics. One of my favorite websites is Freakonomics. And they've recently posted an episode where they did sham surgery. And basically what they would do is they would take people with arthritis, arthritic knees. They took some people and they treated them with nothing. Other people they gave arthroscopic surgery to. Other people they just flushed their knee with saline, but told them they were getting arthroscopic surgery and they wanted to see if it would help. And the amazing thing is the placebo surgery did work. They would actually put somebody to sleep. They would cut a hole in their knee. They would pretend that they did the surgery. They would stitch them back up. And those people who had the fake surgery actually said that their pain went away with their arthritis after. And so the placebo effect is really an amazing thing. So that's actually some of the new things that they're doing with placebos. All right, let's move on. We're going to talk about a completely randomized design, okay? So this is a type of experiment, okay? So a farmer wishes to determine the optimal level of fertilizer for his new soybean crop. You want to design an experiment that will assist him. So we're going to follow these steps to design an experiment. So the idea is we want to identify the optimal level that maximizes the yield. So the response variable will be the crop yield, okay? So we need to identify some factors that would affect crop yield. So that would include fertilizer, precipitation, sunlight, the method of tilling the soil, the type of soil, the plant, and the temperature. So in this experiment, we're going to use 60 soybean plants. We can call those experimental units. We're going to list the factors or the variables and their levels, okay? Factor is another word for variable. Typically, I'm going to use variable in this class. So the fertilizer, this is the factor that we're going to be set at 3 different levels. So we're going to measure the effect of varying this level on the response variable, which is the yield. And we're going to set the level of the fertilizer as follows. So we've got 60 plants, 20 are going to receive no fertilizer. That's going to be our control group. We want to see if the fertilizer helps. 20 will receive 2 teaspoons of fertilizer per gallon of water every 2 weeks. And 20 soybean plants will receive 4 teaspoons of fertilizer every 2 weeks, okay? So in other words, so here's the main thing. I'm going to probably give you guys a test, and I'm going to ask you to create a diagram that's going to look like this. And the thing that gets most often left out is we're going to do the random assignment. That's going to be the first thing we're going to do. We're going to randomly assign our plants to 3 different groups. So group number 1 is going to get 20, group number 2 is going to get 20, and group number 3 is going to get 20. Group number 1, we're going to give the treatment of no fertilizer. Group number 2, we're going to give 2 teaspoons of fertilizer. Group number 3, we're going to give 4 teaspoons of fertilizer. And then we will compare the yield between those 3 groups of plants and see which one grew best, okay? Now, Some other things that we need to worry about. Precipitation, okay? Now, unless we've got it in a greenhouse, we can't really control the amount of rainfall, but we can control the amount of watering we do. So each plant will receive the same amount of precipitation. We could also maybe put this in a greenhouse, and then maybe we could control the water even better. Sunlight is definitely an uncontrollable factor. Unless you put it in a greenhouse, then you could make sure they all get the same amount of sunlight. Method of tilling, we can control this factor, and we'll use Roundup to get ready for tilling the soil. The type of soil that we're going to use, we can control certain aspects of the soil, such as acidity. So hopefully we'll use the same type of soil. Each plant will be planted within a 1 acre area, so it's reasonable to assume that the soil conditions are equivalent. There could be variation from plant to plant, and so to account for this, that's why we randomly assign the plants to a treatment. And remember, that's the first step that we should do. And hopefully, when we do that, the plants will be evenly distributed. Temperature is another factor that's uncontrollable unless we put it in a greenhouse, but theoretically, it should be the same for each plant. And so hopefully that will be the case. Step 5, we need to randomly assign each plant to a treatment group. We could do that 1 through 60. We talked a little bit about randomization last time, and then we could generate 20 numbers. The plants would then get treatment A. Next, we would number the plants 1 to 40, and we would randomly generate 20 more numbers. Those next plants would be treatment B, and then the remaining plants would get treatment C. Now we can till the soil, plant the plants, and fertilize according to the schedule. At the end of the growing season, we're going to determine the crop yield for each plant. Step 6 is to determine if there are any differences in yield among the 3 groups. But the main thing that I want to point out here, this is an illustration of a completely randomized design, okay? So when I ask you to draw a diagram for a completely randomized design, I'm looking for something like this, okay? So any questions on completely randomized design?
So I'm assuming that for the uncontrolled variables, you would take that into account in your final analysis. So if it was like, say, like 90 degrees and some of the plants, all of the plants wilted, then you would conclude that it was the result of the temperature or something along those lines.
Well, so one of the nice things about experiments, well, it's both a good and a bad thing. If you really want to control this so that you want to verify that it's the fertilizer making the difference, put it in a greenhouse. And so then you can control the temperature, you can control the moisture, you can control the weeds, you can control everything. Now the problem with that is when you put something in a greenhouse, you've put it in an artificial environment. And so it may be that when you put it out in regular sunlight, the fertilizer doesn't work as well in regular sunlight. And so that's the advantage to not using a greenhouse. But the idea here is if you're putting this out on a farm, hopefully you're not putting these 20 plants next to a shade tree and these 20 plants in the scorching sun. Hopefully you're putting these out so that they all have the same amount of sunlight. And so therefore, the sunlight will be the same for everything. The watering will be the same. The amount of rain they receive will be the same. And so therefore, the main difference would be the fertilizer. So, but yes, if it's 90 degrees and it kills all your plants because scorching, you'd probably say, well, I don't know if that's the fertilizer or not. That would be a different issue. But assuming that it's not a terrible sun, then the main difference you could conclude would be the fertilizer. So does that make sense? Okay.
Yes.
Perfect. All right. So Am I missing some stuff? We didn't really talk about observational studies. Let me see. Did I open up the wrong thing here? We did 8 last time. Oh, I did open up the wrong thing. Okay, these are the wrong notes. Those are my old notes. I will mention this. There are some fantastic studies on Freakonomics. Freakonomics is one of my favorite statistics podcasts. There's also a good one called The Hidden Brain that uses a lot of statistics, and 538.com. While experiments are generally better, considered better than observational studies, there are problems with experiments. I will post these. You don't have to listen to these, but I think it's really interesting on why experiments aren't as good as sometimes people say. This is a really interesting one from The Hidden Brain about placebos. It's really interesting. There was a guy named Alfred Mesmer. You've probably heard of being mesmerized. Okay, so it's named after this guy named Alfred Mesmer. And one of the things that he would do is he would dress up like he'd have a lab coat on, and he would do all these amazing, I don't want to call them optical illusions, but he was very charismatic, and he would make people believe they were being healed when he wasn't doing anything at all. But people would get healed. And so there is something to this placebo effect. And this whole thing on Alfred Mesmer was pretty interesting. Okay, we've talked about that. We've done all this. Okay. Okay, so let's do this example here. There was a placebo-controlled double-blind study. In fact, this is a good thing. We're going to test you guys and see if you remember. A placebo-controlled double-blind study was done to see if Lipitor prevents cardiovascular disease. 2,838 subjects participated, aged 40 to 75, with type 2 diabetes. They had no prior history of cardiovascular disease. So subjects either took 10 milligrams of Lipitor daily, of which we had 1,479 subjects, or placebo, which was 1,411 subjects, and the response variable was cardiac events. So I want to see how good you guys remember your population. So based on this, let's start at the bottom. I'm going to pick on Zach Johnson. So Zach, can you tell me what is the population in this study?
I would say my guess is the population is the 2,838 subjects.
Okay, no, that would be the sample. Because we have more than 2,838 people in America, right?
Okay, yeah.
Okay.
So I guess it would then be all people with cardiovascular disease.
Actually, no cardiovascular disease. So here's the interesting thing. So you correctly identified the sample. That's the sample. The population are people aged 40 to 75 with type 2 diabetes and no history of cardiovascular disease. So they kind of gave that to you after. Okay. Does that make sense?
Yes.
Okay. So yes, we're looking at all people. So all people, notice these are, middle-aged adults and higher with type 2 diabetes and no history. So that would be your population. Okay. Sample would be the 2,838 subjects. And all right, so some people may say, why are the drug and placebo sizes different? So ideally that we would want them the same. Now these are pretty close to the same, okay? But the problem is, and this is a real life problem, a lot of times when people get in a study, if they think they're getting the placebo, they'll drop out. And so it is very common for the placebo group to be smaller than the drug group. One thing you can do is you could maybe compensate by adding a few more placebos so that when people drop out, although these numbers are pretty close together. But that's one of those things that it's just something we've got to deal with. If people think they're getting the placebo, a lot of times they'll stop participating. Okay, so steps for designing an experiment. Okay, identify the problem. We need to be explicit. Okay, don't say, I want to see improvement. This is vague. How do you know if improvement is made? So let me ask you guys a question. This is a true story that happened to me, so I want you to pretend you're me and tell me how you answer this, okay? So when I was a student at the University of Utah, I had a doctor wanted me to help her design an experiment. And she was a dermatologist, and she was trying to improve people's habits. So what she wanted to show was to improve people's habits with regards to skin cancer, okay? And so that was my first question was, how do you measure that? Okay. So how would you measure if someone's habits with regards to skin cancer were improving? Can you guys give me some ideas?
Well, I think for one thing, if they're doing something that's producing negative effects, if they stop doing that, then that would be considered maybe an improvement.
Okay, but once again, that's kind of vague. How do you identify that?
I guess maybe if you wanted to quantify a particular instance of maybe like sunburns, then tracking a more positive trend of a lack of sunburn.
Okay, so sunburns, you can track that, I guess, but that's not what she asked for. She wants improvement into how people are preventing sunburns. So tracking sunburns doesn't prevent them, okay? So how would you track preventing sunburns?
Would maybe something like controlling how much sunscreen the person wears while they're in direct sunlight be one?
Okay, so we would have to track whether the person is using sunscreen. Is that right? Okay, so that's pretty good, but let me ask you a question. How do you track that? Are you gonna follow people around and say, are you putting sunscreen on?
I guess that is a tricky thing to
That's
test.
gonna be very hard to do, right?
Yeah.
I mean, you hire a bunch of students and then, make them all stalkers and say, are you putting sunscreen on? But that's gonna be hard to track, right? Okay. So that's why I say
Do you take a
a
poll
lot
of
of
that?
times you got to think about this. How are you going to track that?
Do you take a poll of a large group of people so that even if there's some outliers, you have a basic group of how much sunscreen people are using doing a poll?
So you're saying ask a poll so that they have to track it themselves. Okay. Now that's great because it takes the onus off of you as the tracker and puts it on the patient or the subject. Of course, once again, we have some problems with is the subject going to tell you they put more sunscreen on than they actually did? That can be a little bit of a problem. But yeah, as far as tracking, it's going to be way easier than Olivia's idea of following people around and seeing if they're doing sunscreen. Okay. Anything else?
Would you track like the number of, I guess if they don't have cancer, they wouldn't have cancer cells, but I was going to say track the number of cancer cells and when they go up and down.
Well, hopefully people don't have any cancer cells.
Right.
But the idea here is we're trying to improve their habits. So you guys are focusing more on the results, the sunburns, the cancer cells. We're trying to prevent those from happening. And also, that's going to be expensive to be taking cancer cells. So how do you prevent sunburns? How do you prevent cancer?
Layers
What
of
are some things
clothing.
besides sunscreen that we can do?
Staying out of the sun when it's really hot outside, like when the rays are strong.
Okay.
You'd also have like if you're wearing long sleeves, short sleeves during the summer.
There we
Like a
go.
lot of
That's what I was-
farmers would wear, that I was around growing up, they'd wear like thin long sleeve like shirts, so that way they wouldn't get sunburned.
Yeah. So long sleeve shirts, that's a good idea. Hats, that's a good idea. So as you can see, a lot of times these are kind of hard to think about. And so when you're designing a study, you have to really think about what are some things. So in my case, one of the things that she said was she was going to teach a class on wearing hats and sunscreen and long sleeve shirts and things like that. And so, so what she decided to do, by the way, Ellie Nagel, why do you come up UU? That's kind of funny. University of Utah?
I don't know why it's doing that. It did that yesterday too. I don't know why that is
Oh, that's weird. Are you a Utah fan?
No, I don't even
No,
know.
I am. There's nothing wrong with being a Utah fan.
I
Don't say no.
them over BYU, but
What's that?
I said I would pick Utah over BYU any day, but
Oh, that's good. I'm glad to hear that. All right. So anyway, I lost my train of thought there. We were talking about sun. Oh, what she decided to do was she said, okay, I'm going to give everybody a pre-test. Are you wearing a hat? Are you wearing sunscreen? Are you wearing long sleeve shirts? Are you staying out of the sun? Those kind of things. Are you wearing sunglasses? And so she would give everybody a pre-test, then she would lecture, and then she would give everybody the same test afterwards and say, are you going to wear a hat? Are you going to wear sunglasses? Things like that. And so that way she could measure the difference in the responses. So it was a fairly easy way to collect the data. The problem is, yes, everybody's probably going to be like, yes, I'm going to wear a hat and I'm going to wear sunglasses because I just saw how awful the surgery was and the treatments were. But are they really going to do it? So that can be the trade-off there. So anyway, identify the problem. Being explicit, that can actually be a very difficult part, one of the most difficult parts of designing an experiment. Step number 2, determine the factors and variables that affect the response variable. You should almost always include age and sex. There are usually differences by age and there are usually differences by sex among the other variables that you consider. Step number 3, determine the sample size. Sometimes the book calls this experimental units. We're going to talk about sample size calculations later. Determine the level of each factor. As we talk about fertilizer or sunscreen, are they using SPF 20 or SPF 40 or SPF 60 or whatever? And of course, we're going to randomize those treatments. We're going to conduct the experiment where we will randomly assign the subjects to treatment groups and collect and process the data. And finally, we will test the claim. That's usually done through confidence intervals and hypothesis tests. So just as fair warning, when we get to confidence intervals and hypothesis tests, that's when this class gets hard. It's just very difficult. And the question is, can you infer that these results are generalizable? Now I talked a little bit about the plants. Sometimes it's nice. A greenhouse is nice because you can control the variables, but sometimes when you put plants in an artificial environment, they might react differently than if they do out in the real world. So, all right, I think we've talked about all those now. So once again, this is the completely randomized design that we're talking about now. The other experiment that I just talked about with the the pre-test and post-test is what's called a matched pairs design. And it can be an experimental design in which the experimental units are paired up, okay? So the pairs are selected so that they are related in some way. So one way to conduct a matched pairs design is use the same person as a before and after treatment. So in the example I just gave, she's got a pre-test and a post-test. It's the same person. You compare the person's answers before and after. Another common matched pairs design are twins studies. Those can be very interesting, especially because twins, especially identical twins, usually have the same DNA. You can also do a husband and wife. Maybe you could compare the husbands versus the wives as some sort of a matched pairs design. Same geographical location. There can be lots of things. The difference is, whereas with this study we did with here, we had 3 different treatments. With the matched pair, obviously you're limited only to 2 levels of treatment, one for each person in the pair, or before and after. Okay. So in a matched pairs design, go ahead.
Sir, my laptop is at 8%. I'll stay in the class until it does, but if I cut off, it's not voluntary.
Oh, I'm sorry. You forgot your plug today, huh?
Yeah, I was gonna plug it in for this class, but I realized it didn't have it. So.
Oh, bummer. Okay, well, hopefully you can watch the video after.
Yeah, I'll finish up on the video.
Okay. All right. So in a matched pairs design, one individual will receive one treatment, the other receives a different treatment. The matched pairs design is randomly assigned to the treatment group using a coin flip or a random number generator. We then look for the difference in the result of each matched pair. Okay, so before and after, you can actually subtract the correct answers or something like that. One common matched pairs design is to measure the response variable on an experimental unit before and after it's applied. In this case, the individual is matched against itself. So these experiments are often called before and after, or pre-test and post-test experiments. So an example of a matched pairs design, this will be the diagram that we're looking for. So an educational psychologist wants to determine whether listening to music has an effect on a student's ability to learn. So one way we could design an experiment to help the psychologist answer that question, we can use a matched pairs design. And in this case, we might match according to a student's IQ and gender. Okay. So gender could play a role in learning to music. So the idea here is we're going to match students based on IQ and gender. Okay, so we'll put 2 women together. Perhaps they'll have the same IQ, 110 to 115 range. So for each pair of students, we're going to flip a coin to determine which student is assigned to the treatment group of a quiet room, and then the other one gets music playing in the background. So for example, maybe a student would be given a statistics textbook and told to study section 1.1. After 2 hours, they will enter a testing center and take a short quiz, and we will compute the difference in the scores of each matched pair. Any difference in the scores will be attributed to the treatment. Okay. Now, one of the differences, just to compare this with the completely randomized design, with the completely randomized design, we always do, the first step is to randomize right off the bat. Whereas that's not the first step with the matched pairs design. The first step is to match the students according to gender and IQ. And step 2 is to randomly assign to a treatment. Okay. So it's step 2 rather than step 1. At this point, we can administer the treatment to each matched pair, and then we can compute the differences of the scores in the exam. Now, one note about the relationship between the design experiment and simple random sampling. It's often the case that the experimental units selected in the study are not randomly selected. So for example, that case that we gave earlier about the Lipitor, we picked people that were 40 to 75 years old that were diabetic, okay? So clearly those people are not random. We've specifically selected them. However, we'll do this because we're trying to test for a common trait such as diabetes or high blood pressure, and we're trying to test to see if our medicine works on high blood pressure or diabetes or whatever. So in this case, we asked people to volunteer for the study. Once we have our subjects, we will use simple random sampling and assign them to treatment groups. And so the idea is with random assignment, we assume that the patients are similar at the start, and we will assume that it's the treatment that's the only difference. And so therefore, the treatment caused the difference between the observed and the response variable. So any questions on matched pairs design? Okay. All right, we've also got randomized block design. And I forgot to include a picture here, so I'll draw a picture here in just a minute. So randomized block design is used when they're divided into homogeneous groups called blocks or strata, okay? So within each block, the units are randomly assigned to treatments. You can block on age, gender, or something else. And so let me just mention this. I'm going to get rid of that example. That's not a good example. So often men and women react differently to drugs and also to advertising. Okay, those are two common things. And so a lot of times, because of this, we often use a randomized block design where the blocking variable is gender. Okay, so I will say this, a lot of times the randomized block design looks a lot like the completely randomized design, and I'll show you the difference, okay? Actually, before we do, remember with a completely randomized design, randomization is the first thing that happened. It's not the first thing that happens with a randomized block design. So if I'm going to do that, let me pull up a paint for a minute, okay? So with a randomized block design, okay, maybe we'll use a blocking variable as gender, okay? And so in this case, maybe we'll have men and we'll have women, okay? So the first thing we're going to do is we're going to break up into men and women. This is one of the most common ways to do a randomized block design. And so the idea here is once we've broken up people into men and women, then at this point is when we're going to do our randomization. Okay, so we're going to randomize the men and we're going to randomize the women. Okay, and I'm going to try to keep this simple. And the idea here is we'll randomize the men into a couple of different groups. We'll randomize the women also into a couple of different groups. And so you'll have here group 1, group 2, group 1, and group 2. Okay? And at this point, then it's going to look like a lot like a completely randomized design. You're going to, for each group, you're going to give some sort of a treatment. Treatment 1, treatment 2, treatment 1, and treatment 2. Okay? And so then, once you've given them the treatment, of course you could have more than 2 treatments, but at this point, we're going to compare our results and compare our results. So you notice this looks very similar to the completely randomized design. The main difference here is at the beginning where we're using a blocking variable. We're breaking up into men and women in this case, and then we're going to randomize. Okay, so there was a and the reason why we do this, based on a true story. So back in the 1960s or 70s, I don't remember when it was, but there was a drug that treated insomnia pretty well, and they also found that it treated nausea. And so women, especially when they get pregnant, will experience nausea. So they said, oh, well, we've got this drug, and I wish I could remember the name of it. I don't know why I can't remember. I'll have to look it up. But at any rate, there was this drug, and they said, here, take this drug. It will help you with your morning sickness. The problem was, what happened was it did treat the morning sickness, which was a wonderful thing. The problem was it gave birth defects, like really severe birth defects. And so as a result of that, a lot of times, drug companies just said, okay, we don't want to cause birth defects. We're going to eliminate women from all of our studies because we don't want to deal with this side effect, which on the one hand was a good thing. Clearly, we don't want to create birth defects. But on the other hand, now we have all these drugs that are out here that have not been tested on women. We don't know whether they're safe or not for pregnant women, especially. So it's a tough thing. And so so a lot of times they're now resorting to this randomized block design, and they're trying to be careful. And so drugs that may be fine for men because men don't get pregnant, that we're trying to find out. Whoops. Here, let me copy this. I'm going to paste this in my notes before I mess it up again. So a randomized block design can be very useful for especially drugs. Now, advertising is another thing. Women often react differently to men. I'll just tell you, my mom and my sister really love to watch the Hallmark Channel. It's very romantic, which is great, but I swear it's the same story over and over and over. But some women like that. My mom and my sister are an example of two women who like that. Whereas I'm more into sports, and so a lot of times when we do testing, we might test things using the randomized block design. And so those would be two examples of things where men and women are very different. So anyway, I think I'm done with chapter 9. So do you guys have any questions on chapter 9 as far as experiments?
I don't have a question about the lesson itself, but do we have access to the notes on your PowerPoint from today?
Yes, I think I posted that, although I added this new thing here and I fixed a few spelling errors. So I'm pretty sure. Let me actually, before I answer that, it's a yes. I thought I posted those up there.
Yeah, I've been following along on the notes, but they're the old ones.
Oh, they are?
Yeah.
Okay. So I will update that. If you go to assignments here in Canvas, I will update today's because I made a few changes there. If you go all the way at the bottom, I have, oh, don't I have? Oh, lecture notes right there. It's under worksheets from class. Usually I call it lecture notes. That's funny. So I've got the lecture notes, I think, for the rest of the semester already up there, except for I'm going to update 8 and 9 so that it has today's updates on there. So any other questions?
Real quick, this isn't really to do with the class, but my name showed up as my middle name instead of Tyra. So when you do the attendance for today, just know that I'm here. It showed up as my middle name.
Oh, you're. Oh,
Tyra,
is that how?
yeah.
So you're Tyra, because I remember you logged in last time. Okay, so Tyra and Bryn are the same person. Supposedly, there's a way to change that in Canvas. I saw something on Facebook when another teacher said it, and I don't know how to change that. But yeah, you can change that theoretically. But Tyra and Bryn, thank you for being the same person.
Yeah, you could call me either as long as you pronounce them right. I don't mind.
Okay, and I know last time I think I pronounced it Tyra because I didn't know, but Tyra, yes, I will remember that. So, okay, any other comments, questions?
Was the drug you were looking for, was it the thalidomide?
Thalidomide, thank you. I should give you extra credit for, maybe I'll give you extra credit for finding that. I told that same story today in my Math 2040, and they came up with all these drugs, and I couldn't remember, but it was thalidomide.
I work in a pharmacy, and that's one that we don't dispense anymore. That's one we're not allowed to dispense anymore because of that.
Oh, wow. Yeah, it was some terrible, terrible birth defects. It was terrible, so. All right, any others, comments, questions? Okay, so your homework on chapter 9 is due Tuesday, right before class, and I will have a quiz there as well. Oh, and by the way, let me mention this because some people ask me. So I have to manually update your homework scores, and I'll probably do that after class every Tuesday and Thursday. So if it shows you have 0% in Canvas and you really did 100% of the homework, don't worry, it'll get updated. It's a manual process. I'm just excited. You're the only class I've ever had that I had integrated homework. Even if I have to do it manually, at least you have it. So so don't worry about that unless you really don't do your homework, then worry about it.
One quick question.
Okay, go ahead.
So when I took the quiz on Canvas, I just wanted to make sure you can't log out of it, right? Because I accidentally clicked on it versus the homework, and then I was kind of stuck taking it really quick, which I wasn't ready for. So can you log back out and like log back in and take it?
No, I only give you like 10 or
to do
15 minutes on the
one.
quiz.
Okay.
Yeah, so do that all in one sitting.
Sounds good. I just wasn't prepared this time. I'll be better next time.
Oh, no problem. And also, I would just mention, these quizzes aren't proctorio quizzes. And so proctorio is going to be a lot more strict on that when we get to the test. That'll probably be in a couple of weeks. But I do know also, I do know that people have lost internet connection and usually text me freaking out, oh my gosh, I lost my internet. And I will let you back in. Hopefully that doesn't happen consistently. But yeah, I know it happens. But I will say this, as far as the test goes, do not print the test. I used to tell people to print the test, and then I found out that if you press print, proctorio kicks you out of the test. So when I give the test, don't print it. Just write down all your questions, and then you can take pictures of them and upload them, and I'll grade them. And of course, I tried to grade the quiz. I think I got most of them done. The multiple choice, obviously, the computer can grade those automatically. But the essay ones, I have to manually grade those. Oh, and I did most of those. I might still have a few left. So, any other questions? So it's coming up UU for Ellie Nagel again. That's so funny. You're going to be my Utah fan, and I love Utah, so that's good.
Good, that works then.
So I always joke about, you can't wear any BYU shirts or Yankees shirts. I don't have a problem with the Blackhawks, but I am a Bruins fan there, Noel, just in case, so. Are you following the playoffs there in the NHL?
Not so much right now, a little busy, but
yeah.
Yeah.
My
Sorry
Bruins
about the
made
Bruins,
the second
though.
round. happy about that. So, and I just hope there's a Jazz game today. Who knows? Well, in fact, I'm going to log in and find out if there's a Jazz game today, because I might or might not go. So, all right. So I will let you guys go, and see you all on Tuesday.
Thanks.